Welcome to Change by Design, the podcast where we shine a spotlight on engineering transformation. I'm your host, Chad Jackson, and each week we dive deep with leaders driving real change in the world of engineering. From breaking down barriers to challenging the status quo to fostering cultures of innovation and resilience, our guests share their journeys, lessons learned, and actionable insights to help you become the catalyst for positive change in your organization. Whether you're an engineer, an executive, or simply passionate about making a difference, you're in the right place. Get ready to be inspired, empowered, and equipped to engineer a better future, one change at a time. Guy Zur, welcome to the show.
Hello, Chad. Thank you so much for inviting me. I'm extremely excited and honored to be here.
Yeah, same. Looking forward to the conversation. So I think a good place to start would be to talk a little bit about what you're currently doing. What kind of role are you fulfilling? Who do you work for? That's good context for the rest of the conversation.
Perfect. So I'm Guy. I am officially the Director of Test Systems and Automation in CARIAD, or to be more specific, in CARIAD US. My responsibilities are mainly everything on the right side of the V for hardware and BSP development. So let's say once the design team finished the work, they hand it over to me to say, hey, it's ready to be tested, and then hand it over to production line. I perhaps move too fast. What is CARIAD? So it's interesting. CARIAD is the in-house development wing of our company for the entire Volkswagen Group. It's a very challenging company and very interesting to be there in the midst of the revolution that is happening currently in the automotive industry.
Yeah, good, excellent, great introduction, and I'm really looking forward to this. A lot of times we talk with folks that are very involved with the left side of the V, so connecting with the right side of the V is going to be really very, very interesting discussion. So before we jump into those kind of details, I'd love to hear about your origin story. Like, how did you arrive at this point in your career? How did you get into test? Love to hear a little bit about that.
Well, I felt it's determined for me. I was born with a solder and resistors and PCB in my hands from my inception. This is what I used to do. Maker as a child, building kits and robots and playing with electronics, intrigued by how the universe works. And it was no question for me that when I can, I'll be an electrical or electronic engineer. And well, I was fortunate enough to be accepted to one of the best universities in Israel and study electrical engineering over there. When I finished, this was no question. I'm going to continue with my passion, which is hardware and the connection of, electrons to something physical. And I started as an FPGA designer, which was very, very fascinating to see how FPGA plays a very important part in complex and big systems. As designer for an FPGA for thermal imaging cameras, mainly in the defense industry, it was my first time seeing big systems, complex systems, defense system, process. It was kind of me throwing to the deep water and trying to breathe and keep my head above. It was an excellent experience. After that, I decided I want to see something a bit different, and I was fortunate to be accepted to a startup company where we designed a special chip for one, which it's called OTP, one-time programmable memory. We designed a chip there, working with big vendors like Micron or trying to compete with them. It was very interesting to see the move from big scale to small scale. And this startup unfortunately failed. And this was kind of a big slap in my face. And I said, I spent 4 years of my life in a startup. Now what? And then I said, okay, I want to go back to my passion, which is big systems. And throughout this startup, I also studied system engineering, becoming a master in system engineering. And I understand the importance of system engineering process to the succession of complex systems. And the fact that the startup failed was an excellent lesson for me, and it really influenced me in my real life. And a lot of people kind of told me, Guy, you failed. It was a startup that eventually didn't succeed. I think the fact that where I am right now is part of the failure of this startup that really helped me to understand what interests me, learn from the failure, what didn't work, and feel it on really on my flesh, right? These are
Yeah.
hard memories that I carry with me until this day about these failures.
Yeah.
Then I said, okay, let's do something big. And I moved to the aviation industry, and I was fortunate to work in a company called Elbit Systems. And there we designed the first augmented reality glasses for commercial aviation pilots, which was extremely interesting, revolutionary, greenfield project, 0 to 1, everything new. There as being the system integrator or the technical project manager, it depends who.
Mm.
How do you define different companies of different roles? I was exposed to how to integrate multiple disciplines of engineering, and it
Oh,
really took what I learned in my master of system engineering into into effect, which was extremely interesting to see how we can combine the theory with the actual work. Um,
yeah.
from there was an opportunity to move to Canada and continue with my commercial aviation journey. Um, and I continue to focus more on the right side of the V and integrate complex systems for cabin pressure controller and for communication devices inside the airplane
Mhm.
with
Mhm.
Honeywell, all big numbers, big players. Um, then there was a shift to the automotive industry. I moved to work
Big shift.
for Flex and work with Argo AI and
Yeah.
Motional on their autonomous vehicle systems. Again, I can talk hours about it, and I'm sure we'll dive into that later. And that was a segue to where I am right now, leading the right side of the V in CARIAD US for our BSP and hardware
Yeah.
development.
That's great. That's great. I mean, the journey you take affects who you are. And yeah, you can't get to where you are today without everything that happened in the past, successes and failures. So I hear you on that front. Absolutely true. Um, let's talk a little bit about change agents. Change agents leading change within engineering organizations, test organizations, verification, validation. Mm, I'm really curious to hear from you. How do you define a change agent? What do you say are kind of the bounds, responsibilities, skills, experience? Talk to me about that a little bit.
So my definition of change agent is a leader and a revolutionary, someone who not only identifies things that doesn't work, a person who proactively convince and steers the organization to the path that this individual believes as the right path of the organization.
Mm,
So a change agent is, I think, is a combination of a passionate person as well as a leader with vision that is able to influence others, but need to have a strong base in believing that this individual knows what is the right way, because a lot of people will question you throughout the way. But
hmm
the way I perceive it, again, a change agent is something very individual. That's at least how I perceive that.
Yeah, yeah, I think that's great. I love how you define that. I think those are a lot of kind of traits and characteristics of a change agent. I completely agree. Um, what do you think are the most important factors that influence the success of a change agent? Like, what would you say are key characteristics and traits? You mentioned a few in your definition. You talked about a leader, a revolutionary. I'd love to hear a little bit more about that.
I think, yeah. So leader, no question asked. You need to be a leader to be a trade agent, because you need the ability to influence others. You need the ability to carry others with your way. But also, you need to build trust. You need to show that, for example, if you fail, if you did something wrong, you take responsibility. And this is something extremely, extremely important that I saw throughout my career. It's important to acknowledge mistakes and failures, and a lot of time in front of everybody. This is how at least I build trust. When I come in and say, hey, you know what? I was wrong. And I see people really appreciate me saying that. Other things, professional. You need to be professional. You need to understand the engineering metrics. You need to have arguments to show why your way is the right way. And these are things that I've done throughout my career, showing, hey, we need to shift the organization to use this methodology, for example, for requirements management or traceability or test coverage, and build a process out of multiple standards, for example, that I initiated and created. And I provided examples why this process is beneficial to the organization. Let's go back to your question. Other characteristic I would say is good communication and empathy, the ability to listen to others, to understand what are the other side's concerns, not to move them in the direction that I'm suggesting, requires a lot of empathy, a lot of understanding the other side. I think you see a lot of soft skills are required to be a change agent. Just hard skills of being professional, being a good engineer, I think is not enough. The last item I want to have, which relates to all the others, would be the cross-functional alignment, the ability to speak different language with different engineering discipline, to translate your goals into the software team and explain them why moving with this approach of unifying all the test procedures and creating one test architecture for the entire product will be helpful for them. I need to come and convince them by creating less APIs, less DLLs, show them how they will benefit from that. And likewise for the mechanical team, explain them why having a unified approach for test procedure across multiple projects will save their design time eventually, because there will be a library of test procedures, for example, that they can take from and create a use case for lessons learned that they need their buy-in and need their support in tracking that and adding information to this lesson learned. I need to explain to each discipline in different language why it will be beneficial to them. And then, of course, we have testing department and human interface that takes to enter.
That's great. That's great. Anything else off the top of your head?
Plenty of other things like clarity, vision, and to be a visionary and provide a roadmap to show like where are we heading to? What's the end goal? Okay, explain that it's going to be hard at the beginning. Kind of alignment. These are the things. Kind of say it's not going to be easy, but this is what we will benefit from that. Persistence and patience. That's also like need to be persistent. I am like a lot of time people tell me no can do. No, it's impossible. No, it's against the standards. Like the company doesn't allow that. We have a process. Why are you changing the process? It works. So I need to be persistent and come and convince one person and then later say, well, we already agreed we're going to change the process. Here is how we move forward. And it's like a dance, 2 steps forward, 1 step backwards to become a change agent. At least that's from my experience. But you need that I enjoy the way. You need to be also very resilient person and say, it's okay. It's going to be hard today, but eventually it's going to be fun.
Yeah. Yeah. What a great perspective. I love that. I think that's spot on and really, really great examples. Okay. So a question for you. So it sounds, and I'd love to, get an answer for this, that you've acted as a change agent in different parts of your career. So I want to validate that.
Yeah.
But secondly, has being a change agent been an additional set of responsibilities on top of your normal responsibilities? Or were you in a dedicated change agent role? Does that question make sense?
It does. And
Okay.
the answer is it was added because I'm thinking out loud. You know what? One
Sure.
company that I was hired, they didn't hire me as a change agent. They say, hey, you have a task to do, just do it. And then while doing the task, I say, hey, the process here is not good. The process here is not good. Let's improve. So I started with my own discipline that I was tasked to build. So I created
Mm.
my own my own changes in my own wheelhouse inside my department of design verification and validation. And I built a good process. But gradually, as the process was created, I started to have more and more dependencies from other departments, from other disciplines. So if I'm on the right side of the V, from the left side of the V, they need to deliver me inputs. And then I said, okay, let's talk about the handshake between us. If we use Polarion system, which fields should be specified in Polarion? Polarion as a requirement management system and test management system as well. So we defined with the system engineering lead at this time, that was in Flex, um, which fields should be defined in Polarion if it would be if the requirements is very well defined. We create a checklist of fields to be reviewed, and then gradually I started influencing about the process with other disciplines in the company. So for a question, I started as kind of a job description to build my own department. And when it worked well, then with the success, then the expectation grew in the company, and they say, okay, let's try to do a similar process with other departments. And then people came to me and say, okay, let's talk and implement that on others. In CARIAD right now, for example, I'm in the process of implementing a process because the company is still figuring out which type of processes are good for the high speed and high pace we're working on right now. So I'm still acting as a change agent in my discipline, and the same thing, I'm influencing others in the same in adjacent disciplines, hardware and software, to make sure we have a good process that eventually will allow me to do my job in a better way. And I can provide example if needed.
That's great. I mean, yeah, I think you're not alone. I think there's a lot of people that are given ownership and responsibility for a function in engineering. And as part of that, because so many other things are changing, right? I mean, the amount of software in vehicles has been exploding and continues to grow exponentially. That you're going to have to change and keep pace over time. So I think you touched on a really
Exactly.
relevant point there. Yeah, yeah,
One
that's
one
great.
important
That's great.
important thing, I one important thing I want to add a bit more about context of CARIAD. So when CARIAD becomes the software and hardware development house for the Volkswagen Group, um, it's sometimes it's not our comfort zone, because the industry used to rely um, on tier ones. The industry used to rely on other companies who did build to spec. And now we're building the
Hmm.
capability in-house. And this takes some of people in this organization outside of their comfort zone, because they used to manage other companies and now they need to own more responsibilities, um,
Yeah.
and build a process. And that's where I'm helping with my past experiences doing that in a tier one company. I'm doing the same now
Yeah.
for CARIAD.
Yeah. Yeah. I mean, yeah, I absolutely, I hear you. That's got to be very difficult because if you outsource it to another company, you manage the inputs, you manage the outputs, and the way they execute it, you can kind of be hands off. But if you're bringing it in house, you get exposed to all the challenges, all the difficulties. Mm.
Yes.
But I find it very interesting in that usually when you bring things in house, it's because there's a recognition from executives that, okay, this needs to be a core competency that we need to have. We need to get more closer and intimate with that function. Um, why? I'm curious, and this can be a general statement, doesn't have to be specific to CARIAD. But why do you think that V&V is a competency that needs to be brought in house or more closer, more intimate for an OEM?
Because of the complexity of the projects of the automotive industry nowadays, where it's become with the software-defined vehicle, everything is software-centric, as well as complex hardware in the loop, safety
Hmm.
criticality to comply with safety standards for the automotive. The complexity of the systems have created them not only as a black box as used to be previously, but as a gray box. So it means that I
Hmm.
need to understand the full structure of the hardware and the software in order to effectively assure the systems that I am allowing to be sold to the market comply with stringent automotive standards as well as common sense, I would say, standards that these products are reliable.
Hmm.
So I need to have this level of knowledge to understand the system, the block, or say the ECU. ECU is 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 the box that I'm selling to that I will be installed in the vehicle. I need to make sure that it's
Yeah.
fully tested and also has the ability to communicate with other boxes in the car itself. So I need to have this knowledge. Now it's critical because the OEM now doesn't want to share that with the tier one. You never know where the information goes to, and that's commercially classified eventually.
Sure.
So
Hmm.
this is the main reason: the complexity of the car, the changes, by the way, in architecture of the cars right now, with again the software-defined vehicle revolution, and that forces more things to be in house. And what's interesting, by the way, is if you'll go back 100 years ago, back to where the cars were invented, this is how the car started. Uh, Ford did everything, and then later they start outsourcing as part of becoming more cost centric. So
Mm.
I think what's happening now, it's exactly what happened 100 years ago when new cars were introduced. Now there is a revolutionary in the automotive industry, which creates new technology. All the companies, or most of them, keep the cards close to the chest. They say, okay, I want to have the advantage. I want everything to be in house and not shared with others. I'm
Hmm.
pretty sure that once everything will stabilize, everything will go back to cost reduction and outsourcing.
Hmm. Yeah, that's a really interesting perspective, and I think you're right. Um, we're in a phase where we moved out of commoditization of a lot of these aspects of the system, and but it will return at some point back to being a commoditized aspect of the system. Mm.
That's what I think. And just in another thing, just to mention, you could see the
Yeah.
same thing happening in the aviation industry. So again, I came from aviation, I moved to automotive. It was similar with, let's say, Boeing, for example, it became more of integration and spec companies. And
Hmm.
unfortunately, again, according to my perspective, this is also the lead for sort of multiple accidents we saw in the past years because I think they gave too much. They gave too much to
Yeah.
other tier ones and didn't keep all the cards close to the chest.
Yeah.
But you could see that across
No, that's
multiple
interesting.
industries of complex systems integration.
Yeah. 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 Um, that leads into a really another part of the discussion. So let's shift gears and talk about that, where um, you know there's a really interesting dichotomy in the industry, and one is for so many years we have seen a huge emphasis on digital approaches for verification, and yet today I see a lot of companies that have to wait to do physical validation because a lot of times maybe the hardware isn't ready, or digital methods aren't mature enough. Um, could you talk to me a little bit about kind of the pendulum swing between digital methods and physical methods, and where are we today, and which direction is the pendulum swinging next as a trend? I'd love to get your perspective on that.
Okay, so this is my perspective, and it's important to say because I've been in the industry and I'm checking what my peers are doing and where I am. I still perceive myself as an old school. I see and hear and exposed to all the digital twin trends, and I see the advantages in that. But for me,
Mm.
as a person who owns the integration of hardware and software, um, I see less advantage in putting all this effort in creating a digital twin for an ECU, um, rather than have a quick design, have the first
Mm-hmm.
prototype in house, and then see the problem. My
Yeah.
experience showed me that creating a digital twin will create a new set of problems, which I still didn't find that as extremely beneficial, because you have two products that you need to manage. You have the hardware product and you have the digital twin product that you need to develop or manage.
Yeah. Yeah.
And it's
Okay.
management, it's debugging. There are some false positive failures that you will see, and I heard about the advantages. I talked to people who implement that. They told me, yes, we
Mm.
found that bug that was very hard to find unless we had a digital twin. But
Mm.
from my perspective, the amount of time and energy you've spent on finding the bug, I think that by having a real hardware, perhaps at the prototype level, you
Mm.
could have found similar bugs already. Now, it's
Okay.
important to say that my point of view is hardware and base software. Like think about the computer and the operating system that runs on it, not user
Yeah.
application. So I'm not involved with that. There are perhaps more advantages of using and digital twin in um, more of full software centric applications.
Okay. All right. No, that's really interesting. I mean, there's a nuance there that is important to kind of suss out. Um, can you talk a little bit about, well, let me give you a little bit of context. So I know that, with so much software coming into, these systems, and there's a lot of agile methodologies that companies have used around software. A lot of companies that have hardware software systems, they've tried to apply to agile on the hardware side as well in terms of development. And so number one, are you seeing agile being adopted, and yeah, what's the degree of success there? But the other thing I want to ask about is frequent prototypes. So there's that concept in agile. It's one of the principles where you build frequent prototypes, and that's been the software side of things, but the concept can be applied to hardware software systems too. And you do that continuously throughout the process. So talk to me about Agile. Talk to me about frequent prototypes. Do you accelerate prototyping and test? Love to get your perspective on that as well.
So for this question, I'm all in, as opposed to the previous question. My approach is prototype, prototype, prototype. Start with evaluation board, get an EVB from the vendor, try to connect as many off-the-shelf products together to have a prototype. Because when you or after that, I'm sorry, design a first PCB. I think that the money you would spend on prototyping, you will learn more than by the virtualization and creating a digital twin. And my
Mm.
approach right now is create. So in the automotive, we have usually 3 or 4 design cycles: EV, A sample, DV, B sample, PV, C sample. Sometimes we have D sample. So usually for
Mm.
a normal development cycle in the automotive, you have 3 prototypes. Our approach here in CARIAD is we will have sometimes 5 prototypes to see the problems as they happen. Because when we do the prototyping, we see so many things that we didn't even think about it. And that reminds me, remember I think it's the metrics, just a second, it will come to me.
Yeah.
Um,
The
okay. So that reminds me of Rumsfeld matrix, which talks about the unknowns. So there are four types of unknowns, right? You have the known, you have the known unknowns, you have known knowns, you have unknowns, and you have knowns unknowns. And what really scares me is the unknowns. And when you do a digital twin, usually you will focus on what you know and perhaps what you know that you don't know. Sometimes, if you're smart enough to figure it out. But the things you don't know and you don't know that you don't know, these are the ones that I am looking for. This is become the beacon for myself. Like, I want to know more. I want to know what I don't know. And only by physical prototyping and creating multiple versions, then I start to see problems. And I can give you some very simple example, like mechanical. So we designed a prototype that should fit in all of the cars, and only by creating multiple prototypes and trying it out in different vehicles, then someone said, hey, there is this type of vehicle that we missed the requirement and it doesn't fit. And I'm not sure that, and I want to find these problems as early as I can, because this required a catastrophic or not catastrophic, a significant change in the mechanical design of the product, which led to a layout change and eventually some hardware and software changes. And we were able to find it early in the product life cycles because of the fast prototyping. So just a simple example for something we didn't even know that we don't know, okay? Because it was specific vehicle with a specific something super different orientation of the installation that we didn't know. And this is how we were able to solve that. More than that, more of the interfaces that we figured out how to network interfaces, for example, things that we thought would work and eventually they didn't work. I would say we found plenty of other problems with the fast prototyping, aside of user interface and installation, but also from hardware and testing, thermal stress, things that we didn't even think about. We found them, things that really surprised us in regarding to component that doesn't meet their specs, for example. We received specs, we integrate plenty of new components which are new. Everybody say, well, it should work, and it works, and we're the integrator. Then we see that it doesn't. So
no, that's a great perspective. And so if I'm following you, the unks, which is what I know them for being called, the unknown unknowns.
Yes.
If they're unks, then you don't know enough to model your digital twin with enough fidelity to uncover those unks. And frankly, the only way you will is if you build a prototype physically and actually try to test it. That's when you're going to get exposed to the full set of risks, whether you considered them or not. That's what I'm hearing you say. Is that fair?
That's exactly my point. That's exactly where what I am thinking. And it's proved itself out. Yeah, go ahead.
Yeah, no, that's good. That's good. So, so it sounds like the strategy there, and the one that you're advocating, is to accelerate physical prototyping as early as possible, so you can find those unks and other issues as early as possible, so you can start working on resolving them before you get designed into a box or constrained by other commitments. That makes a lot of sense in my mind. Anything else on the timing in terms of when that should happen during the development process? I mean, are you starting to do that early on, even on the left side of the V?
Yes, definitely. And that's what we do in CARIAD, which I find it, I want to say, more revolutionary than all the previous companies I used to work. We were more, I would say, classic V cycle designers. And in CARIAD, we say, hey, we don't have full requirements. It's okay. We don't have the full requirements. Let's make assumptions, write what we know, write what we know that we don't know, create a first prototype based on what we have so far. We want boots on the ground. We want the engineers to start integrating. So we start creating the first prototype even we're not mature. And I mentioned, I think that to you in a previous conversation, that this takes me out of my comfort zone, because I cannot. How do you want me to write a test procedures? How do you want me to test a product when I don't have requirements? Like it's how. But I need to keep running. I need to adjust because I see the advantages of benefit of that, and that's kind of positive mindset and growth mindset to say, well, it is what it is. We need to succeed. It's a very competitive industry. This is what will get us to where we need to.
Yeah, that's fascinating. And by the way, you're not alone on this front either. There's an article published by the CEO of Hermes. Hermes is a startup building, a hypersonic jet. And the op-ed that he wrote in particular focused on, we've kind of lost a competency about building things in fast iterations and building prototypes and learning from them. And part of it is certainly uncovering these unks and issues that you couldn't find otherwise, but also building up knowledge and lessons learned for the next project that you can leverage. You're more likely to uncover the issues. So can you talk a little bit about that too?
So I want to touch something that we started the conversation. I think what we see is that companies, or at least managers, are afraid to fail. And because of that, they go to the safe harbor. Let's do more simulation. I can say, well, I did all the simulation. I did everything I could not to fail. But the problem, it's related to what you said about terms, is to create a safe environment for failure. We want to fail. Okay, fail is okay. If we fail, we grow. We fail, we learn.
Mm-hmm.
And that's at least something that I learned throughout my career. I want to fail. I want to find the problems, because we grow out of that. We need to celebrate the failures. And this is the right, at least from my perspective, the right approach. Manufacture or create prototypes, integrate, test as much as you can. Simulations is good. Do simulations. But you need to understand where to draw the line. When too much simulation is too much, and perhaps the digital is better for the digital digital twin is better for higher application layers, but perhaps for more of the physical layers, boots on the grounds and actual manufacturing, I think you will benefit more. At least that's what my experience taught me.
Yeah, no, okay. So that's really good insight into this difference in strategy. Let's talk a little bit about how you enable it. And I'd like to talk a little bit about culture. You talked about tolerance for failure. I think is a way you described it, but I think there's an aspect of professional or career security. Like having a culture where, okay, if you fail, are you going to be lambasted? Is it going to negatively affect your personal career as a result? And that comes top down from an executive perspective. And you've worked at a lot of different places, and you don't have to name names here, but I'm curious, can you compare and contrast different cultures that you've been a part of where it worked and where it didn't work? I'd love to hear about that.
So luckily, I'm fortunate enough to be working in Israel. Then I worked in Canada, and now I'm in the US, and I see the different cultures, and the culture that is extremely failure oriented or let's say advocate for failure is Israel. There is an excellent transparency, excellent approach. It's let's try. It's okay. We need to learn from the failures, and you see that from top management that we tried. Let's document it. Make sure we document why we wanted to do that, and then document what were the outcomes. And regarding the organization tolerance, one of my managers, I remember first managers in my career, told me, "Listen, it's okay to make mistakes, but make it twice. Then it's become systematic and problematic. So make sure you document the mistakes. You don't repeat the same mistakes. They kind of told me don't step on the same brake twice, right? So don't get hit twice in your face. And that's something that really mold my personality as a manager and as a leader. And I brought that with me to Canada. And in Canada, it was challenging. It was a bit more different to see different mentalities, where people were afraid to talk about their failures. But what's even more, they were afraid to tell me about their peers' failures. Kind of, I think he's doing something wrong, and little by little, with very delicate approach, I sat with people one-on-one and start to create this culture of it's okay to fail in my organization. So I could see that. Now, Silicon Valley is in between, I would say, Canada and Israel. So it's still
okay. Yeah,
it's still okay to fail. Like, we want to fail, it's okay. But I see still some resistance. I still see some fear of failures. But I think it's a combination of the location, like the physical location atmosphere. It's a combination of the company itself and the organization culture as well. So it's hard, but at least what I'm building is organization where it's okay to fail and document it. And the thing that I'm doing the most is speaking up for myself. Hey, I take responsibility for this failure because we were all in the same room. We said this would be the right approach. And it seems that we missed something. I'll take responsibility for that. And when people see that I'm stepping up and taking responsibility, they feel more safe to admit with their failures. And only then may succeed. We cannot move forward with people, putting their stuff under the carpet and moving. I need to have transparency about the failures and why didn't work and why we were not able to receive or to have product with the right Wi-Fi throughput, for example, because we had a problem with the design of the antenna, for example. So these are the things that I need people to come to me and sometimes point a finger on others. But in a good way. It's important in a good way. And we talk about it. And it's building culture.
Yeah. And failure is definitely an opportunity to learn. So hiding them under the carpet, I guess it eliminates the opportunity to learn from it. So I hear you. Let's talk about some other kind of enablers of this strategy. So, you're working on systems, multi-domain systems, hardware, software.
Cool.
Obviously, model-based systems engineering is a big deal right now. There's a lot of proliferation and adoption of it, but there's also document-based approaches. Can you talk a little bit about what you all use to kind of pursue this strategy from a technology perspective? I'd love to hear a little bit about that.
My approach is more document-based. This is what actually worked for me. And I am fluent in creating the right infrastructure in document-based system engineering, in defining the right process of documents, which level of information each document should include. And from that, define the first level of the MVP, minimum viable product, or define what would be the phase 2 and phase 3. I can provide you or work with you and show you a very detailed document mapping list from the requirements or stakeholder requirements down to system requirements, to hardware requirements, software requirement, then to implementation of the hardware, implementation of the software, then integration document when we put everything together, and then test procedure of testing the features that are ready, and then verification procedures, validation procedures, and full traceability from the stakeholders' requirements on the left side of the V to the right side of the V, where we have the test artifacts. My expertise is in creating the right set of tests that will use the least amount of effort to test as many features or many requirements as possible. And this I'm doing really with requirement or document-based test approach, and teaming up the entire group, the hardware and the software, and sometimes mechanical team, to show them which type of tests are needed to test as many features or many requirements to get it, to test as many features is validated. Then I can use that for the end of line and repurpose that and not reinvent the wheel sometimes.
Let's continue on with this discussion around tactics to enable this, this prototyping and testing strategy for V&V. Let's talk a little bit about the technology. Now, model-based system engineering, MBSE, is kind of growing in adoption right now. A lot of people are turning to it to address this complexity issue. What are you using as enablers on the V&V side of things? I'm really curious about that.
Thanks, Chad. This is a very good question. I still perceive myself as perhaps as an old school. I am using document-based system engineering, and the tools I'm using are mainly to show traceability from stakeholders' requirements, system requirement, design documents, implementation for hardware and software, and then integration. And then going back to the right side of the V, where we have unit testing and then module testing and system testing, and then system validation. So my expertise is creating the right set of process to assure that we are testing exactly what we need to test, and reuse as many test procedures across the right side of the V to be very cost and time efficient. And I'm achieving that by creating a very detailed and meticulously planned test procedures. So from day one of the project, using these document management systems that we have, we define the backbone of the test infrastructure or the test requirements. And from there, we define the implementation of these tests. So my approach that I'm bringing with me to all the organization I'm in is mainly design to test approach. So when we have the requirements, immediately I'm stepping in, I'm saying, okay, this is how we will test it. And then we flow back to the requirements and tell, hey, it's not testable. Here we have problems. These requirements are not very well defined. So we do this conceptual thinking of integration as in parallel to composing of the requirements. And that's what I've been doing throughout my career, making sure that the right side of the V is being taken care of from day one of the project. And it created a significant effect on all of the projects I was involved, because we identified problems before they happened, throughout very detailed documentation and traceability process, and meticulous, of course.
Right. Makes sense, and it sounds like it's certainly working for you. So, can you talk a little bit about data collection and any use of like hardware in the loop or hybrid simulation, physical testing approaches? To what extent have you leveraged that, and what's your experience been?
Rich experience. I've been doing that quite a lot. For hardware, the loop tester, model simulation of some feature through our hardware in the loop testers. These are things that I've been doing. Regarding hardware loop and data collection, my experience showed me collect everything. Every 2 seconds with the systems that at least I am defining, we have a tick that at least every 2 seconds, I need to collect full status of all the logs, all the registers, everything that the system creates. My job is to find these elusive bugs that you would never think that they exist. That when a specific interface or specific string of communication goes on one interface, Then there is something unrelated on a different interface. And unrelated could be something that will affect the user, or it could be radiated emission, for example, that will exceed the standards and the unit will not pass local homologation and certification accreditation that we need to do. So I need to connect all the dots for all the possibilities.
That's
So
great.
so that's kind of what I need to achieve in my definition of the test process and procedures.
Yeah, that's great. Good stuff. Okay, so we talked a little bit about kind of the underlying technology. We talked about culture. Let's take a second to talk about personnel. Um, how have the profiles of the people you need in V&V changed? You can go back 5
Wow.
years, 10 years, whatever's relevant, but I'd
Yes.
love to hear that perspective.
Wow. This is changing crazy, like crazy. And with the entrance of AI, it becomes very interesting to the characteristics of the people that I need. I feel that the person I need, sometimes I had some employees that used to call them, I am jack of all trades, master of none. I need someone who understand the full flow of the electrons, from electron up to how it's being displayed, or what's the software that creates the Android application on the display for the user. So I need people with full understanding and the ability to ask critical questions through each and every step in the way, from the flow of electrons up to the application that generates the display to the user interface. What's the refresh rate? What's the interaction between different applications on the operating systems? What is the throughput on the bus? What is the termination? Which type of wires are we using? Is it twisted pair, not twisted pairs? I need people who understand the full path, and this is extremely challenging to find people which have two things, which have the passion to understand that. But also, what I found interesting, not a lot of people want to be in this position because they say, well, I studied software engineering. I want to do software. I studied electrical engineering. I want to do electrical design. I don't want to be system integrator. I don't want to take someone else's artifacts and make sure that it works with others. So it's challenging from both reasons, from people who sometimes want to have this tunnel vision and say, this is my expertise and I want to continue that. And on the other hand, people say, well, I studied electrical engineering. I want to do electrical engineering for per excellence. And it's hard to find the people who enjoy really having the full visibility of the product and taking artifacts from others and find problems with them.
No, that's really interesting because it sounds to me like the skill set you need in system integration, it not only covers the thing you need to test, but also the test system, right? So all the data loggers, all the processing tools you're going to use to process the data, and all the instrumentation on how you're going to measure it and measure the requirement satisfaction. Whereas on the design side, the scope is actually smaller. That's fascinating.
Exactly. So I'm connecting the dots. I'm making sure, for example, that if we have CAN communication in parallel to Ethernet communication, to make sure I'm not testing it or I'm not over testing it. For example, one of the tests we do, we apparently we were over testing the product. So I need to review and make sure I'm not over testing or over stressing the CPU performance in parallel to additional communication that I interact with the product that we're designing. So these are the kind of the challenges currently that nowadays I'm facing within CARIAD to ensure that we're testing to what we need. And if you remember what I told at the beginning, we're moving forward with not full requirements. So that's sometimes a bit challenging, but with the maturity of the product, the maturity of requirements will come.
Gotcha. Yeah, that's great. That's great. Well, let's wrap it up. I'll ask you one more question. If you were to give advice for a change agent, say fulfilling somewhat of a similar role to that you're fulfilling, what would be like the top 3 pieces of advice that you would give them?
The first one was find your allies in the organization. This is the most important thing. You need to find the early adopters in the organization that will work with you. This would be the first. The second tip I would be, trust your inner voice. Is you think it's the right way, continue with that.
Yeah.
And I would say the last one, wear the armor every day to work, because people will try to undermine you and try to attack you and show that you're not sometimes doing the right thing. So come with your armor, but make sure you have a lot of arrows in your quilt sometimes, which means you're prepared. Well, that's what I meant. Like, make sure you're prepared with answers and support documents to why you think that you are leading the organization in the right way.
Yeah.
So this would be my 3 tips.
Excellent. Yeah, that's great. Thank you so much. Well, what a great conversation. I really appreciate you sharing so much. I think a lot of people are going to get value from it, and you're going to help other people in very similar positions. So again, thank you so much, Guy Zur, for coming on the show today.
Thank you, Chad. I really appreciate it. It was a pleasure for me. I really enjoyed. Thank you.
Thanks for tuning in to today's episode. If you enjoyed the conversation, make sure to follow or subscribe on your favorite podcast platform so you never miss an update. We'd love to hear your thoughts. Send us a message, leave a review, or join the discussion on our social media pages. Until next time, take care and talk soon.